Hi there, welcome to this tutorial on Java interview questions for freshers. In this tutorial, we would start off with a few basic questions for freshers. This is the part 1 of the tutorial, and we would look at questions like what is platform independence? Why is Java popular? Differences between C++ and Java? What is object-oriented language? And also a lot of other questions which we will discuss as we move on into the other parts of this tutorial. So let's start with the first part of this tutorial, which is to focus on the first question, which is what is platform independence? I mean, we hear a lot of things. A lot of people say Java is platform independent. What does platform independence really mean? I mean, what do people mean when they say platform independence? That's the first thing which we'll discuss as part of this series of interview questions. Let's get started. What you see here is an example Java program. So it's just a hello world program which prints hello world to the output. So what does platform independence really mean? The platform independence means that when I compile this program, I get a hello world app.class. So the class file which is generated out of the compiler, you can run that on Windows, on Unix, or Mac. Any operating system that you have, you can run that program on it. That is what platform independence is all about. So basically, the program which you write, you can run it easily on any of the platforms without modifying anything about the program. So the same program that you write, you will be able to run it in Windows 32 or Windows 64-bit or Unix or Macintosh. So this is basically what is a platform independence. A platform independence is one of the main features of Java, and that's one of the main reasons that Java is very popular. You write Java program once and you can run it anywhere. You can run it on any of the operating systems that are present in the world. That is because of something which is called a JVM. The JVM stands for Java Virtual Machine. So this Java Virtual Machine is the most important component of Java being platform independent. There would be a separate JVM for Windows, there would be a separate JVM for Unix, and there would be a separate JVM for Macintosh. Once you install a JVM on a particular operating system, you can run any Java program on that particular machine. So if I install a JVM on this Windows 32 machine, then I would be able to run this hello world app.java and also any other Java program that I write on that machine. So you can write this hello world app.java once, and then you can run it on any of these machines without making any changes. That is the most important thing about platform independence. The platform independence, Java achieves it through the JVM. So the JVM is the most important, the critical part of the platform independence of Java. However, older languages like C, C++ are not platform independent. What that means is if I write a C program for Windows 32, then probably I need to make some changes in the program, then compile it, build it, and then deploy it into Unix to be able to run it in Unix. The same thing in a Mac OS. So you might need to change a few more things, and then you need to be able to run it on, then you will be able to run it on the Mac OS. So that is not the case with Java programs. In Java programs, you can run it once, make the jar or a class file, take the class file or the jar, and you can directly run it on any of the other operating systems as long as you have the Java virtual machine available. So that's what is called platform independence, and this is very important question in terms of the interviews in Java. Now let's move on to the next question, which is why is Java so popular? I mean, if you look at the world, a lot of people use Java, a lot more than C, C++, or any of the other languages which are coming up. So why is Java so popular? I think uh, like this is due to uh, two very important reasons. One is Java is platform independent. So we discussed earlier about how Java achieves platform independence. So Java is platform independent, and that means if I write a program, Java program, it will run in any of the operating systems. It will run in Windows, it will run in Macintosh, it will run in Unix, Linux. Wherever I want to run it, I can run it. So it's very easy to write a program which would run in all the machines. So that's one main reason, I think, that's platform independence. Since Java is platform independent, so it's very popular. And I think the second reason why Java is so popular is Java is object oriented. We look at what object orientedness, like object orientedness means in further, but like object oriented programs are easy to maintain. So and Java is one of the I mean, it's not the first, but it's one of the first popular object oriented languages, and one of the popular pure object oriented languages. I say pure object oriented languages because even in C++, C++ is object oriented. I mean, C++ had object oriented capabilities, but when you look at it in like you can write programs which are not object oriented programs in C++, but in Java you can only write object oriented programs. You cannot write programs which are not object oriented. So I think these are the two reasons why Java is so popular. So one is platform independence, and the second one is Java being object oriented. So that's our second question, which is why is Java so popular? And the reasons are platform independence and object orientedness of Java. If you have any other reasons, then probably you can put them in the comments, and that would be useful for others who would do the interviews. The next important interview question usually asked is, what is the difference between C++ and Java? So Java is an object-oriented language. C++ is an object-oriented language also. Yeah. Then what is the difference between them? So let's get into the details. One big difference between C++ and Java is a concept called pointers. Those of you who are programmed in C and C++ would know something called pointers. Pointers are references to where a particular value is stored in memory. So you have this all set variables and stuff, right? You have a variable A, B, C. Like a pointer can store where a variable is stored in memory. So if I have a variable called A and it's stored in a particular location in memory, so it's stored somewhere in the memory of the computer, right? That's the address of that is called a pointer. In C and C++, it is allowed to use pointers. That means you have complete idea about where a particular variable is stored in memory. This is one main difference between C++ and Java. In Java, you don't have pointers. So in Java, you don't have any idea about where a particular value. You cannot reference a memory location. Like you cannot reference a value by using the memory location, and there are no pointers in Java. So that's the first difference. There are no pointers in Java, whereas C and C++ had pointers. And the other thing is, like there are concepts like structures, unions in C and C++. However, Java is object-oriented language, and hence it doesn't have anything called structures and classes. All that it has is something called class and objects. So in C++ we use structures and unions, and also class and objects to an extent, but in Java we don't have structures and unions. All that we have is class and objects, because a class is, for me, a class is nothing but structure plus the methods which operate on the structure. So you can say a class is nothing but a structure, that's different data parts, plus the methods which operate on the data, the methods which act on the data. So that's basically what a class is. So Java doesn't have separate thing called a structure, but it just has this thing called a class. So that's also an important difference between C++ and Java. Structures and unions are not there in Java. Yeah, the other important thing is in C++ you can dynamically allocate memory. So you can directly say I need this much amount of memory and that much amount of memory, and you can directly manage the values which are present in memory. Whereas in Java you don't have anything of that kind. In Java there is an automated memory management process called garbage collection. This garbage collection is done by the JVM. So the JVM takes care of everything related to memory. So in Java you don't need to worry about how I would need to deallocate memory, how I would need to allocate memory, and all that kind of stuff. In Java, all that you need to do is create a new instance of class, or create a new instance of something, and once the class is out of scope, Java automatically removes it from memory. Whereas in C++, if we allocate some memory, then we need to deallocate it. So all that memory management has to be done by the programmer himself. Whereas in Java, all that is automated. All that, if whenever I need an object, I create an object, but I don't need to worry about deallocating the object. That is automatically taken care of by Java virtual machine in a process called garbage collection. The other main difference between C++ and Java is C++ supports multiple inheritance, whereas Java doesn't support multiple inheritance. There is a trivia here. In Java, you can extend multiple interfaces, but you cannot extend multiple classes. So in truth, Java doesn't support multiple inheritance of classes. You can extend multiple interfaces, but you cannot really extend multiple classes. So that's another difference between C++ and Java. Java supports multiple, C++ supports multiple inheritance, whereas Java does not. And Java is a pure, instead of saying fully, I can call it pure. So Java is a pure object-oriented language. That means in Java, you can only write object-oriented programs. Whereas in C, what I mean by object-oriented program is in all Java programs consist of classes. So you cannot write a Java program which does not have a class. So, but in C++ you can write you can create a file which does not contain a class. So that's another difference between C++ and Java. So in summary, these are the main differences between C++ and Java, which is C++ has a concept called pointers, structures, and unions, and in C++ you have to do memory management yourself, and C++ supports multiple inheritance, and C++ allows also to have source code which are not classes. So these are the main differences between C++ and Java. Let's move on to the next question. What is an object-oriented language? So what is really an object-oriented language? So basically, object-oriented language is something where the most important things are called classes. So you create a set of classes which interact and give you the functionality that we need. The most important concepts in object-oriented languages are encapsulation, abstraction, inheritance, and polymorphism. Right now we'll discuss a few basics about it. Later in the advanced tutorials we'll look at them in detail. Let's look at what encapsulation is. Let's look at the first concept of object-oriented programming called encapsulation. I have two simple classes in here. One is called the cricket scorer. The cricket scorer class is used to calculate the score in a cricket match, and we have a test scorer. So if you look at this test scorer right now, the test scorer actually creates an instance of the cricket scorer. So cricket scorer is equal to scorer is equal to new cricket scorer. And if you look at this, this is incrementing the score. Let's say a batsman hits a 4. So what it's doing is scorer.score is equal to scorer.score plus 4. So if you look at this, this program, the test scorer, is actually accessing a variable called score from the scorer class and incrementing its value by 4. So what is happening is score, which is actually something which is present in the scorer class. So the variable called score is actually present in the scorer class, and I'm taking that value and incrementing by 4 and again setting it back to the scorer. This is not a good example of encapsulation. What do I mean by that? So score is something which is internal to the scorer class. So that score should not be allowed to be able to, we should not be able to access it outside the scorer class. And all the manipulations to the score should be done directly in the cricket scorer class. That is what encapsulation is. So how do I do that? Is by making the score object private, and then you'd see that I would not be able to do score this. So then if I want to increment the score, the way I would do it is by saying scorer.4. So what I've done here is created a method. So in this cricket scorer class, I created a method called 4, and I'm saying score plus is equal to 4. So whenever test scorer wants to increment, want to say that a 4 is hit, so it would say scorer.4. And if this test scorer wants to know what is the score, then it can use the get score method. So instead of the I can say scorer dot get score, and I can do a system dot out dot print. So if I do it right now, it would show run as Java application, and it shows 4. So the score is incremented. So if I want to hit another 4, you would see that it's 8. So if you basically look at encapsulation, encapsulation is the data and the methods which act on the data. So here I have a method called 4 which increments the score by 4. I have another method called 6 which increments the score by 6. So I will not let the other classes, I'll not let the other classes which are outside the cricket scorer to change the value of the score. So I would only allow them to change the values through 4 and 6. So only the methods which are present in this cricket score class will be able to change the value of the score and not outside. So this is what is called encapsulation. So encapsulation is a very important feature in, very important concept in object-oriented languages. In object-oriented languages, everything should be properly encapsulated. You should not allow a particular class variable to be modified outside that particular class. So that's our first important thing called encapsulation. Abstraction. The next important concept in object-oriented languages is something called abstraction. So what is abstraction? So abstraction is all about hiding the complexity. For example, let's just say you have the mobile phone. So in the mobile phone, when we dial the number and press the dial button, when we press the numbers and press the dial button, it automatically calls the number that we want to call. So there is a lot of things that happen behind the screen. So when you press the green button on the mobile, it has to do a lot of things. It has to establish a connection to the mobile provider, and then it has to check with the mobile provider if you have enough balance. Then there are a lot of things which happen behind the screen. But as far as the user is concerned, the mobile phone is a very easy interface. So all the complexity that lies behind a mobile phone is hidden away from the user. So that's a very important thing. That's also present in software and in object-oriented languages, and that is called abstraction. Abstraction is nothing but hiding the complexity. So if you want, if I want to do a sorting algorithm, I just create a method called sort and implement it in there. And wherever I want to uh, do a sorting, I use the implementation of from the method which I created earlier. So if a new developer is coming and using the sort method, he doesn't need to know how to sort. He just needs to call the sort method, and the sorting would take place automatically. So this is what is called abstraction. The next important concept in object-oriented languages is inheritance. Inheritance, let's look at a small example on inheritance. So if you look at this particular example, we have a class called animal. So animal has something called name. So I also have a constructor here. So here I'm creating another class which extends the dog animal class. So this is what is called inheritance. So I'm saying class dog extends animal, and if you look at it, the dog does not have a name, but it gets name from the animal. Because dog is extending animal, it gets the name from the animal. So if you look at this particular thing, this is a very good example for inheritance. So I get all the code which is present in the animal class because I'm extending it in the dog class. So the dog class also can use all the functionality which is present in the animal class. So if there was a method in here, then the dog class also can make use of it. This is called inheritance. The inheritance is extending another class, so so that we can reuse the functionality in that particular class. We'll look at more examples about inheritance in further interview questions in the advanced parts. Next, another important object-oriented concept is polymorphism. Let's look at an example for it. So if we look at this example, we have an abstract class called animal, and the animal has a method called bark. I'm creating two classes. One is dog and another one is cat, and extending animal. So this dog and the cat, both classes extend animal, and they implement the bark method. How does the dog bark? Bow bow. And cat meow meow. So they offer the implementation. So if I look at this particular thing, I'm creating, this is animal. So animals, I'm creating an array of animals, and I'm putting one dog and one cat in it. So I'm creating an array of animals and putting one dog and one cat in it. I'm calling an animals 0.bark. It would print bow bow. Because animal 0 is cat, it would call this method. And animal 1, if we look at it here, animal of 1 is a, sorry, if animal of 0 is actually a dog, so it says bow bow. Animal of 1 is a cat, and it says meow meow. If you look at this, different methods are called. So here the cat's bark method is called. Here the dog's bark method is called. Even though the same, so here both the animals are of same type, right? So they are of type animal. So even though the same type, on the same type, I have two objects of the same type, when I invoke a method, different methods are called based on what instance it is, what is the type of that particular object. So what is the subtype of that particular thing. So here when it's a dog, the dog's method is called, even though the reference which is used is an animal reference. The reference variable is an animal reference variable, but the method which is called is the method inside the dog class. So this is what is called polymorphism. So this animal, even though the reference variable animal has like based on whatever it is, that particular thing is called. To make it even more clear, I can actually have one reference variable animal is equal to new dog. So if I do animal dot bark now, so if I do system.out.println animal.bark, it would call this method bow bow. Whereas if I change it to cat and now do animal.bark, it would return meow meow. So it, even though I'm not changing anything to the left, so it's still a animal class, but based on whatever is the content of that particular, whatever is the reference object that is pointed to, the method which is invoked is different. This is what is called polymorphism. Polymorphism is called same code, different behavior. So even though the animal.bark, this code is the same, based on what the animal contains, different methods are called. So different behavior is exhibited. This is what is called polymorphism. So polymorphism is also a very important concept in an object-oriented language. So basically, the things that we looked at are the important concepts in object-oriented languages. Those are encapsulation. Encapsulation means we keep the data and the methods that act on the data together. So we have some data in a class, and all the methods that act on that particular data are also present in the same class. We don't expose the data outside. So this is what is called encapsulation. And abstraction is hiding the complexity. So we hide all the complexity and let the other developers use the methods which we already created. So that's abstraction. And inheritance is extending the functionality of one class in another class. Polymorphism is same code creating different behavior based on the content of the object, based on the content of the reference variable. The behavior exhibited is different. So that's basically what polymorphism is. So those are the important things about an object-oriented languages. So now let's look at the next question, which is what are the advantages of object-oriented programming? In object-oriented programming, what we do is we try and model everything in terms of the domain. So if I'm talking about animals, so I'll create a class called animal, I'll create a class called dog, I'll create a class called cat, and I will have inheritance relationship between them. So we try and really model the domain. So if I'm creating a banking application, so I'll have something called an account, and I'll have a savings account, a checking account, and probably I would have a loan account. So I would have different things expressed in the domain language. So that's, and also the interrelationships are between these are also expressed in terms of the code. So that's one of the main benefits of an object-oriented language. So it expresses us to the code would map to the domain, and others can look at this and understand it as well. And also in object-oriented programming, there are a lot of concepts which promote reuse. For example, inheritance. I can extend one class in another class, and I would be able to reuse the functionality which is present in the earlier class. So there are a lot of features in object-oriented programming which promote reuse. So these are a couple of important advantages of an object-oriented program. Let's move on to the next question, which is pass by value versus pass by reference. What is pass by value and what is pass by reference? In Java, what happens is, let's say I have a method called int do something. I'll create it as void, and let's pass an. So let's create a do something method and pass an integer I. So in main, I want to run this program and say I is equal int I is equal to 10, and I'll say do something 10, do something on I, and I'm saying system sysout I. Let's just make these methods static methods, just so that I can directly call them from main. And next I would call I would run this program and see what's the output. So I'm creating a variable I with value 10 and I'm saying do something I. So this do something will say I is equal to I plus 5 and I'm trying to print value I. Let's see what the output is. So if you see, the value which is printed is 10. So I'm putting the value 10 here. I'm incrementing the value of I plus 5. So I'm doing 10 plus 5 15, but if you see, the value which is printed doesn't show that. So let's do it the other way. So in the next one, I would actually create a small class here, class test, and let's say test contains a int I. So instead of passing I want to pass do something test I, and I would say test and test.I is equal to test.I plus 5. I'll move this test class outside. So instead of do something of passing an integer variable, I would pass a test. So I would create an object test. So I will say test is equal to new test, and I'll say test.I is equal to 10, and I'll say do something t, so that the t object is passed. Sorry, t do something test, so that the test object is passed, and I'll do system.println test.I. I'd need to make this class also static just so that I don't have an instance of the test class. So now I'll run this program, Java application. If you see, the output which is printed now is 15. So the earlier when we declared something like int I and we did do something I and printed the value of I, the value of I is equal to 10, we saw that the value of I was not changed, whereas when we send an object, the value was changed. This is the main difference between a pass by value and a pass by reference. When I'm saying do reference I and I'm passing a primitive, I is a primitive variable, so I is an integer, it's a primitive variable, and I'm passing the primitive variable, then what gets passed is 10. So only the value gets passed and not the reference I. So when I change something, so when I did I is equal to I plus 5 here, what happened is the value 10 was passed here and a new variable was created and that was modified to 15. But the old existing variable still remains at 10. So there would be a variable here, there is a I here, and there is a different I here. So the I here is different from the earlier I. This is called pass by value. What we do is we just pass the value. So we say I is equal to 10. So what is passed here is 10. So 10 is passed, and here also 10 value is passed, and that value is copied into a new variable called I, and that new variable is incremented and the old variable remains as it is. Whereas if we pass an object, here I'm passing an object. When I pass the object, what is passed is the reference to the object. So the same object test which is present in here is passed. The reference to that object is passed here, and the reference, we are incrementing the value at that particular value thing. So here whatever changes I do here would be visible in the object test. So when I printed test.I, you would be able to see the value, changed value 15. Whereas if I printed I, you would only see the value 10. So this is the difference between pass by reference and pass by value. So when you pass a primitive, the value of that primitive is passed. So any changes that you do will not be reflected. When I pass an object, you're passing the reference of that particular object. So if you are changing anything in that object, so if I'm changing a value in that object, then that value gets reflected. That is the main difference of pass by reference and pass by value. Next, let's look at the important differences between string, string buffer, and string builder. So let's start with string and string buffer, and then we will move on to string builder. So what are the main differences between string and string buffer? Before we get there, we need to understand an important concept called immutability. So what is an immutable class? Immutable class is one where the content of the class cannot be changed once you have a value in there. So let's just say I do something of this kind. So let's just use the same program that we had earlier. I'll remove this, and let's say str string str is equal to abc. So if I'm doing string str is equal to abc, and then do str is equal to abcd, str.concat d. Let's say we do this. So I have a string str is equal to abc, and I do str.concat d. Actually, what happens with string is once you create the class, once you create an instance of that string, you cannot change the value. So what happens when I do str.concat d is a new string is created with a value abcd. The existing string, which was abc, will not be changed at all. So if you look at it and I do a syst out now and print the value str, yeah, these two. So if I see the value which is printed is abc. It's not printing the value abcd even though I do a string.concat. This is what is called immutability. Once you create a string, the value inside that string would never change. So that is immutable. Whereas string buffer, if I did string buffer here is equal to new string buffer of abc, and did, let's say, str.append d, you would see that the value would be modified. So if I run this, you'd see abcd printed, whereas when we ran it with string, it was only abc. So string is immutable. That is, once you have a value in the string, it cannot be changed, whereas string buffer is not immutable. You can change the values inside the string buffer. One difference between string buffer and string builder is that string builder is not synchronized, in the sense that if I'm using it in multiple threads, then string builder will not be a good class to use, whereas string buffer is synchronized. So string buffer is mutable, that is, a value can change, and as well as it's synchronized. And also when we use a lot of strings, it would have a lot of negative effect on the performance. So if I'm doing a loop and appending 10 times in a loop, then if I'm using a string, then it would create 10 different variables. Whereas if I'm using a string buffer, it would be only string buffer is mutable. So if I'm keeping on appending something to a string buffer, it would not create new objects. It will reuse the existing objects itself. So that's a very important thing. If you are really worried about performance, you should use a string buffer and not a string class. So string class, if you use a string buffer in a loop, that is more, that would create lesser number of objects than if you use a string. So those are the important differences between string and string buffer. So there we are. We are at the end of part 1 of this beginner's tutorial. There are a lot of topics we would need to cover more, and those topics are uh, part of the next parts, and you can see all the topics that we would cover on the screen right now, and also topics for the experienced as well. So see you in part 2. The links to part 2 and also the experience questions would be added down in the description of this video as soon as they are available. Until uh, we see you the next time, bye.